Recording in progress.
Hello. Hello. Am I audible? Hello. Hello. Am I audible? Hello. Hello. So am I audible to all of you? Okay, fine. Jadi, so if it okay for that's fine. Oh, Hello. So dear all, yeah, am I audible? Okay. Am I audible?
Yes, sir.
Okay, dear all students, today we'll start one of the new chapter, that is interrupts. So in the last lecture, uh, we completed, that is that is minimum mode and maximum mode we study. For the syllabus, say, say my screen. What is this? So this is our syllabus. Please all of you come to the syllabus. That is microprocessor. So in that, in the last class, we covered that is introduction system bus architecture. So introduction of system bus architecture we study basic 8086 configurations like minimum mode configuration and maximum mode configurations we study. So today I have to start with the section number 2. So first sections, all the 4 units I have to cover in detail, and also I given in detail study materials to you. Is it okay? Please all of you carry through all the notes whatever I given to you. That is very much essential for your exam point of view. So please you have to maintain safely and you have to refer those notes. Okay. So after that, today I have to start section number 2 as per your syllabus. In that first unit means as per serial numbers 15 interrupts chapter. So in this interrupts chapter, we studied what is interrupt, means definition of interrupt, and types of interrupts we want to study. Interrupt and interrupt service routines we want to study. That is ISP, ISR, interrupt service routine, and maskable and non-maskable interrupts. That is two category, and programmable interrupt controller like 8259 and 8257. So this is the topic for the unit number 5, interrupts. So dear all students, you have an examination in the month of March. It means that hardly you have 1 month remaining. Okay. So within this 1 month, we have to complete your entire syllabus. Please cooperate me. And today we are going to start the fifth unit. Before going to start fifth unit, I will transfer these notes. Whatever my handwritten notes are there, I will transfer to you. So here, come to the microprocessor. Yes, microprocessor DSY group. So here I will transfer unit number 5 nodes. Please all of you come to this microprocessor group. Uh, that is microprocessor. Okay. So yes, please all of you take this. This is a microprocessor. Okay. So microprocessor. Five nodes. Okay. So this is the microprocessor 5 nodes. I think all of you is almost even and some of them are not solid. Is it fine? Yes, okay. So please you save this notes, whatever I say to you now. That is unit number 5, interrupts. Okay. Same notes only I have to referring in the lecture, that is unit number 5. So dear all students, as we now saw the syllabus of unit number 5, that is we have to start with interrupts. So first we will so please, am I audible, right? All of you respond me. Please, am I audible? Anyone is there or not?
Yes, sir, you are audible.
Okay, my screen is visible to you, right?
Yes, sir.
Okay, okay, fine, thank you. So here, at first, we will come to know the definition of interrupts. So in the unit number 5, what is interrupt? The interrupts are generally we say that is some abnormalities, whatever is happened during the execution of program. Okay? So here I give clearly given two definitions. That is, first one, interrupt is a method for creating a temporary halt during the program execution and allows peripheral devices to access the microprocessor. So whatever some abnormal things are happened, that time if the program is going to be a terminate, but the interrupts will help to without termination of the program is going to be executed with the peripheral devices or access to this microprocessor. That's the definition of interrupts. So how we are going to define? It's abnormal conditions with that without termination of the program is should be executed. So in that interrupts, there are two types. That is interrupts, hardware interrupt and software interrupts. So clearly, I have to mention here. It is hardware interrupt and software interrupts. So again, in the hardware interrupts, there are two types: maskable interrupt and non-maskable interrupts. Again, in the software interrupts, there are 256 types. That is 0 to 255. Later, but as per the syllabus, hardware interrupts are there. So maskable hardware interrupts and non-maskable hardware. So here these two are the types and the definitions. So now we will look into that. The first one, hardware interrupts. So hardware interrupts are the interrupts is caused by any peripheral devices by sending a signal to a specified pin to the microprocessor. And also in the 8086 has two hardware interrupt pins, that is non-maskable interrupts and maskable interrupts, or directly we have to say interrupt. Okay. So in this first category, that is non-maskable interrupts, it is a single non-maskable interrupt pin having a higher priority than the maskable interrupts. So the request in the interrupt and it is of the type 2 interrupts. So there are 5 types of interrupts, but the non-maskable is the second type of interrupts. And in this non-maskable interrupts, it completes the current instruction that is in the progress of the execution of program, and it pushes the flag register value onto the stack for the execution. So in the stack, the pushes the CS code, that is CS means code segment value and instruction pointer value of the return addresses into the stack, that is to help for the instruction pointer, and the instruction pointer is loaded from the contents of the one word location, that is 0008, that is 8086 microprocessor. So the code segment is loaded from the contents of the next word location from A 0000A, and the interrupt flag and trap flags is set to 0 in the non-maskable interrupts. And in the maskable interrupts, second one, it is also an interrupt with a maskable interrupt because of the microprocessor will be interrupted only if the interrupts are enabled. That interrupt flag is okay. And it should not be enabled using the clear interrupt flag instruction, but the first completes the current instruction and activates the interrupt acknowledgement output and receives the interrupts typed by say X or any number of types. So the flag register value, the instruction pointer, and the code segments are loaded from the contents of its word and the location, and the interrupts flags and traps set to the 0 in the maskable interrupt, or normally how to say interrupts. So the next one, there is software flags. That some instructions that is inserted into the desired position and into the program to create an interrupt. So these interrupts instructions can be used to test the working of various interrupts handler in the software flags, and the interrupt instruction with a type number with a type 2 number instructions, and the first byte provides the opcode and second byte provides the interrupt type number. So there are totally 256 interrupts in the software interrupts. Okay. and all these execution steps I have to mention here. So all these are used in the flag register, code segment, instruction pointer, and interrupt flag register and trap flags that is set to 0. So for that, there are totally 5 main types of interrupts: type 0 interrupt, type 1 interrupt, type 2, type 3, and type 4 interrupts. So in the type 0 interrupt, it presents the division by 0. So whenever, if any number divided by 0 is what? Infinity, right? So infinity is not solved by the computer because there is no infinity keyword in the computer keyboard also, because still it is not solved. That is still pending. So this kind of things are comes in the microprocessor program that time, that is handled by type 0 interrupts. In the type 1 interrupts, that is single step execution during the debugging of a program at a single step. So you, whatever you are using the F7 key during the execution of interrupts, that is type 1. And in the type 2 interrupt, it represents the not maskable interrupts, type 2, as we studied earlier. And in type 3, this interrupt represents the breakpoint interrupts, type 3. And type 4, that responds the overflow interrupts. Overflow, breakpoint, non-maskable, single step execution, and divided by 0. All these different category of 5 types, that is type 0, type 1, type 2, type 3, and type 4 respectively. Okay. So next, if we will come to the interrupt 3, that is a breakpoint interrupt instruction. It is a 1 byte instruction having a upcode of CCH, and these instructions are inserted into the program so that when the processor reaches there, then it steps the normal execution of program and follows the breakpoint procedure. Okay. So here some breakpoint procedure I have to mention, that is flag register, again code segment, instruction pointer, code segment with the word location, and interrupt flags and trap flags. Everywhere we have to use this in the interrupts. Four to five things you have to remember: flag register, code segment, instruction pointer, code segment with the word location, and interrupts and trap flags are set to be 0 while going to apply the interrupts. Okay. So next one, that is in INTO, is nothing but what? Interrupt on overflow. INTO means overflow. Interrupt on overflow instruction. So in this 1 byte instruction and the mnemonics into interrupt overflow, and the opcode for this instruction. Hello, I think my voice is not audible. Hello. Yeah. Yeah. Okay. So next one is, that is interrupt overflow instruction. It is 1 byte instruction and there is no mnemonics into it. So for that, the condition interrupt instruction, that is, it is active only when the overflow flag is set to 1. Otherwise, it is not active. And the branches to the interrupt handler whose interrupt the number is 4. So here, if the overflow flag is reset, then the execution continues to the next instruction. Otherwise, it is going to be fails. That time, interrupt will comes and recorrect it. So here the execution includes the following some steps. Again, that is a flag, controls, code segment, instruction pointer, and code segment with the location of word location, interrupt flag, and interrupt flags are reset. All these points is applicable to all the interrupts. So this is all about just a brief idea or introduction I given to you in the interrupts. So definition of the interrupts: it is a abnormal conditions is going to be corrected. And types of interrupts, there are 2 types mainly: hardware types and software types. In the hardware types, again 2 types: maskable interrupt and non-maskable interrupt. In the software, there are 256 type, that is not for your syllabus, we will look into later. Okay. So this is just introduction, that is introduction part of your 8086 interrupts. So next I will move to interrupt and interrupt service routine. Second topic, I will move to interrupt and interrupt service routine. So here, come to here, that is uh, interrupt service routine. Interrupt and interrupt service routine. So everywhere you may saw about the server. In the server, many times there is some busy with the server, or server is not get downloaded, or you have to buffering of the server. That many times you may observe in your mobile or computer or laptop while you are going to browsing it. Okay, so that kind of server problems is going to be handled. We have to use interrupt service routine. So in that, while the CPU is executing a program, an interrupt breaks the normal sequence of execution of instructions that diverts the execution to some other program called the interrupt service routine. Clear definitions I have to mention here. That is, while the execution of the program, if it is not going to be executed, all the breakpoint should becomes, and that is going to be get corrected into for the execution. So this one we have to say for interrupt or interrupt service routine. Okay, so for the interrupt service routine, I have to mention some points here. For after executing of ISR, the control is transferred back again to main program which was being executed at a time of interruption. Whenever a number of devices interrupts at a CPU time, and if the processor is able to handle the properly, and it is said to have a multiple interrupt processing capability. So the ISR, interrupt service routine, having a multiple interrupt processing capability. At a time only more than one interrupt it can be handled it. So in case of 8086, there are two interrupt pins, that is NMI and INTR. NMI is nothing but what? That is non-maskable interrupts, and normally we have to say interrupts, or it is maskable interrupts. So in the non-maskable interrupts, the input pin which is means that the interrupt request at NMI cannot be masked or disabled by any means. And in the interrupt pins, however, may be masked using interrupt with it is a 256 types of interrupts types that may from 0 to FFF. 0 to FFF, it means a 2 to 16. It means 256 types of interrupts. So if more than one type of interrupt appears at a time, then the external chip called the programmable interrupt controller is required to handle them. Okay. So this is about the interrupt service routine. That 4 to 5 points is very essential and very important points. These you have to remember about ISR. So next I will move to interrupt, that is maskable interrupts. In the maskable interrupts, it means that it is going to be disabled while going to the execute. So the processor of 8086 also provides a pin number of 80 in the interrupt that have lower priority as compared to non-maskable. Why it is lower priority means it is a disabled one. So in the interrupt, signal is passed to processor which decides the type of interrupt, and the interrupt signal is level triggered and can be masked by resetting the interrupt flags. So that is comes under the maskable interrupts. If the interrupt flag is set to processor and is get ready for responding any interrupt, it and then it is reset to the processor, will not serve any interrupt appearing at this pin once it is executed. Once the processor is responds to an interrupt signal, the interrupt flag is automatically reset. IF, the IF is means what? It's the interrupt flag. If one wants to the processor to further respond to any type of interrupt signal, the interrupt flag should be again set. Again, we are going to be set for interrupt flags. So here, suppose an external signal interrupts the processor and the pin clock goes low at the failing edge, and of the first algebraic and logical unit pulses are appear after the some interrupt signal preventing the use of bus for any other purposes. So the pin clock remains low till the start of the next machine cycle. That is for in the interrupts are maskable interrupts. So it remains till the start of the next machine. That is next trailing edge will be the AAD. For that, the interrupt acknowledgement again goes to low, remains low for 2 states before returning to the high state. The first trailing and the next trailing are this timing diagram I have to shown here. This is the first one clock, that is on off. Regular clock we have to given to a interrupt device, that is ALE. In the first 2 cycles of clock it is going to high, and the remaining 2 cycles it is going to low. Again remaining 2 cycles it is going to low. Again at the end of cycle of T1 and T2, next cycle started, again it is going to be high, and repeat the same process up to the end. Here we have to use the lock. That locker is, whenever it is high, the locker is becomes high, and whenever this is low, it is also low. You see in the diagram of timings. And interrupt acknowledgement, it is opposite of ALE and AD0 to AD7. That time how the data is going to be transferred, only in the high state. At this state the data is going to be transferred after recording of all the things. Okay, so that is interrupt acknowledge sequence of 8086. So here for non-maskable interrupt, the processor of 8086 has a non-maskable, and the input pin of NMI that has highest priority among the external interrupts. Highest priority among the external interrupts. So the trap is an internal interrupts having the highest priority among of all the interrupts. So we have to use trap 1, type 1 for the trap, and that is used for divide by 0 type exception. Exceptions means what? Abnormality. So the non-maskable interrupt is activated on positive transition, and it is also association with the non-maskable interrupts is equivalent to an execution of instruction, that is type 2 interrupts. So the non-maskable interrupt pin is should remain higher for at least 2 clock cycles and need not synchronize with the clock for being censored. When the non-maskable interrupt is activated, the current instruction being executed is completed, and then the non-maskable is served. So this is about non-maskable interrupts and maskable interrupts. So totally at the conclusion, in the interrupts, small things, small problems during the execution of the program, that one we are going to be solved by using maskable and non-maskable interrupts. If the problems are big, which is not handled by maskable and non-maskable interrupts, that time we will go for one of the external device, that is nothing but we have to say 8259. That is nothing but 8259. That one we call it as programmable interrupt controller. That one we call it as programmable interrupt controller, that is 8259. Okay, so see here in the syllabus, interrupt service routine. Again you have to study the maskable and non-maskable in this interrupt service routine. So after that maskable and non-maskable interrupts, we will go for programmable interrupt controller. We will go for programmable interrupt controller. So in the programmable interrupt controller, that is 8259, we are used. Why we use this 8259 means whatever the problems, the difficulties, the abnormalities, which is not going to solved by any other interrupts like maskable interrupts and non-maskable interrupts, which is maskable interrupts and non-maskable interrupts. By using these two, If we are not going to solve the difficulties or problems, that time we have to use one of the external chip along with the 8086 microprocessor. That is nothing but programmable interrupt controller. The number is 8259. How we are going to say 8086 8085 like this? It is also one of the microchip 8259 which is externally connected to 8086. So this block diagram and architecture and all the functionality of this 8259 is there for your syllabus. This all the things we have to study. This all the things we are going to study. So that is programmable interrupt controller. So is nothing but 8259. Is nothing but 8259. So in this 8259, uh, the 8086 have a five main interrupt pins, out of which four pins were allotted executed factor addresses except interrupt rather than external devices. So it was supposed to hand over the type of interrupt to the microprocessor. So by using this 8259 interrupts, we have to solve big problems of abnormalities in the microprocessor execution. Okay. So in this again, it will create to difficulties whenever an application with a number of input output devices connected to CPU, and it deserves to transfer data using interrupt driven data transfer types or transfer mode. So for that, the overcome of the difficulties by the maskable and non-maskable interrupts, to overcome of maskable and non-maskable interrupt difficulties, we have to use the 8259 programmable interrupt controller. That is required. That is too much required, and it is able to handle the number of interrupts at a time. So this controller takes a care of number of simultaneously appearing interrupts requests along with their types of priorities. So whenever the program execution, the running of program, based on the priority, if the program is going to be stuck somewhere with any data is not given for are not available, for example, any number divided by 0 is equal to infinity. The infinity is don't know computer what is that. So for that the computer is going to be stuck at that time during the execution of the program. So if the program is stuck that point, this 8259 is going to be supported and resolve the problems or this kind of difficulties. So for that main reason we are using 8259 chip in the programmable interface interrupt controller. Okay. So for that, this is the architecture of 8259. This architecture we have to explain. Yeah, this is the architecture. I think it is visible to you. Again, I have to make it as fine. So in the architecture, there is a one data bus buffer is there, read and write logic is there, cascade buffer comparator is there, in service register, priority resolver, interrupt request, and interrupt mask register, control logic, interrupt acknowledgement, and interrupt with the interrupt request 0 to interrupt request 7, and mainly we call this one as an internal bus. So this is the architecture of 8259. See here, we say 8259 block diagram, or we call it as architecture. Okay. So here, very main essential points I have to mention, that is architecture of 8259. Architecture of 8259. So in that, there is a one interrupt request register, RIRR. That is interrupt request register. See this one, interrupt request register. Next is priority resolver in service register. Okay. So again, sound is off. Hello. Hello, please. Am I audible? Okay. Okay. Yeah, you will get the space. So here in the interrupt request register, this block I am going to explain first. So that time in the interrupt, the data of interrupt request register input lines are handled by interrupt request register internally. So the interrupt request register stores all the interrupt requests in it in order to serve them one by one on the priority basis. That is interrupt request register. Next one is in service register, or we say ISR. That is in service register. So in this in service register, it stores all the interrupt requests. Those are being served. That is the interrupt in service keeps all track of the requests being served. So the priority resolver, the unit determines the priorities of the interrupt requests appearing simultaneously. So as per the priority based on the request, it is going to be resolved it. So the highest priority is selected and stored it into the corresponding bit of the ISR during the interrupt acknowledgement pulses. The interrupt request has highest priority while the interrupt request 7 has the lowest priority. IR0 is the highest priority and IR7 is the lowest priority. That one we have to use it in the interrupt request service routine. Okay. Hello. There is a network problem. I think you may not get the. Hello. Yes. Okay. So there is a network problem. So anyhow, now it's okay. So here in the in service register, this stores all the interrupts request. Those are being served as a ISR and keeps tag into the request being served. So next one is priority resolver. As per the priority level that is going to be executed. So in that priority, the IR not interrupt request 0 is the highest priority and interrupt request 7 is the lowest priority as in the diagram. IR not is the highest priority, IR7 is the lowest priority. It's fine. So in the priority, IR not is the highest priority and IR7 is the lowest priority. So the interrupt mask register, IMR, this register stores the bits required to mask the interrupt and it operates on IRR means interrupt request register at the directions of priority resolver. So the interrupt control logic, this block manages the interrupt acknowledge signals and send to the CPU for serving one of the 8 interrupt requests. Out of 8, one is going to be take it as a priority wise. And also it accepts the interrupt acknowledge signal from the CPU that causes 8259 interrupts, that is PIC, to release the vector address onto the databases. So for that, the data bus buffer, this is tri-state bidirectional buffer interface. That internal 8259, that is bus to the microprocessor system data bus, and the control word status and vector information passes through the data buffer. So now I will explain this architecture of 8259. Architecture of 8259. So here interrupt request register having its 8 requests. I have the IR02, IR7. Priority resolver, in service register. Here data bus, buffer, and read and write logic, cascade buffer. So whatever you are giving a task to the internal bus, this is the internal bus. Into the internal bus, how data lines is spread, that is D0 to D7, 8 data lines, and which is uh, for ready to read and write and writing the logic. Based on that, we have to make it as read, write, and a naught with a control signal CS bar. If it is a full, if the stack is full, then we have to use the cascade buffer for the comparator. So serially 3 lines we have to use CS0, CS1, CS2. So and that is stack pointer with enable. Okay. So these things we have to use it. And this is the control logic. Whatever logic you have to return, you return in the state and going to be executed with the request based interrupt request. The directional mark is here. So this one is a bidirectional and this is a single directional. So that is interrupt requests, priority resolver, in service register. So this is the main. Once the data is entered into this, that is get divided into the data buffers into the D0 to D7, and which is going to ready for read and write, that is read and write logic. After that, if in this queue is full, that cascade buffer is going to be used for the comparator. If it is full, then it's going to be control it. For that, the control logic is here with the interrupt acknowledgement and interrupts. So after that, once the control logic is over, through the control logic, based on the requests, that interrupt request routine, your priority resolver, in service register, that is going to be handle the things and solve the difficulties or problems into the interrupts. So come to this point, that is read and write control logic. During this read and write, the circuit accepts and decodes commands from the CPU. So this block also allows the status of the 8259 to be transferred onto the data bus. So the cascade buffer comparator, which is a block stored for the compares of the IDs all the 8259 used in the system. So there are 3 input and output pins. CS0 to 2 are outputs for the 8259 is used for master purpose, and the same pin act as the inputs when 8259 is the slave. So I think you may observe, right, what is a master and what is the slave. Master means what? Host. Host can sending all the signals or requests, and slave means what? Which is going to be serve it or give the respond. Okay, that is master and slave. So the 8259 in the master mode sends the ID of the interrupts slave devices onto this line. So the slave selected will send its pre-programmed vector address onto the data bus during the next interrupt acknowledgement. Sorry. So next we come to the CS, that is control lines. Say it is a chip select. CS means what? Chip select. So this is an active low chip select signal for enabling ready read and write operations onto 8259. If the interrupt acknowledgement function is active, then it is independent for chip selection. So CS is the becomes a CS bar. That is free from that. And RD bar is nothing but what? This is an active low read enable input to the 8259. A low of this status line enables 8259 to release the status of CPU. So next one is that is right. So this pin is an active low, right? Hello, hello, hello. Am I audible? Hello, hello. Okay. So here there is some network problem. Then also it's okay, no problem. We'll start. So the RD is nothing but what? It is an active low read enable input to 8259. That is read purpose we have to use. WR is used for write purpose, and D0 to D7 used for 8-bit data either to control word or from status word register. This also carries interrupt vector information. So these are the again words 8 vector lines, that is CAS not to CAS to cascade lines. So this cascade lines is useful for the buffering. So and single 8259 provides 8 vector interrupts. If more interrupts are required, the 8259 is used in the cascade mode, and which master 8259 along with the 8 slaves, and 8259A can provide up to 64 vector interrupt lines. So these three lines act as a select lines. That's what we have to use. Cascade lines with the slave of 8259. Next one we are using SP bar enable. So this pin is a dual purpose we are using, and whenever the chip is used in the buffered mode, if the it can be used as buffer enable to control the buffer transceiver, and in this it is not used for the buffer mode, then the pin is used to input diagnosis whether the chip is used as a master or as a slave. So next one is the interrupt. So in this interrupt means this pin goes to high whenever a valid interrupt request is asserted. This is used to interrupt, otherwise the CPU and the connected to the interrupt input of CPU. So next one is the 16, that is IR0 to IR7. These are the interrupt requests. IR0 is the highest priority, IR7 is the lowest priority. Based on the priority wise, it is going to be executed. Next one is interrupt acknowledgement. So this interrupt acknowledgement pin used to stop in the 8259 interrupts, and in the conjunction time the code segment read write, that time it is going to be helpful in the interrupt acknowledgement. Acknowledgement means what? It is to responding. Okay. So this is the pin configuration of 8259 PCC. We have to connect it to this number, and this is the ground. Remaining all the pins whatever I explained up to now, all are we have to mention here. Okay. So dear all students, today just two topics I have to cover. First topic is types of interrupts, that is maskable and non-maskable interrupts, and along with that interrupt and interrupt service routine I have to cover. And the second point I have to cover uh, programmable interrupt controller, PIC, programmable interrupt controller with 8259. That architecture of 8259 I covered only two topics. So I'll give you 20-minute time. So whatever I covered up to the architecture or block diagram of 8259, please read it well. Again up to 20 minutes I'll start lecture. Okay, take it as a note. Whatever I covered till now, please go through it up to the architecture of 8259. Thank you.